We went over, I collected the homework from the yellow sheet. It looks like this. That had matrix addition and matrix multiplication. So I'll need yours when you come back. And we went over the answers, and we're ready for the new stuff. So here we are. Is it on the board on?
Yeah.
Cool. This is called Cramer's rule. It shows up on page 153. And the first thing I need to train you in before we get to Cramer's rule is what a determinant is. And Cramer's rule is going to solve a system of equations. Again, this will be the fifth way. We've done it with substitution, elimination, Gaussian elimination, row operations, and now this is a fifth way to solve two equations and two unknowns. And they look like this. Remember way back when we just started with plain old substitution and elimination? Well, we're going to kick it up using Cramer's rule. To do that, you need to know how to find the determinant. Notice these straight lines? That means the determinant. Every matrix that is square, this only applies to square matrices. Every matrix that is square, 2 by 2, 3 by 3, etc., has a determinant. It is determined by this. You multiply along that diagonal, and that gives us 4, 2 times 2. And then you multiply along that diagonal, but you take the negative of that answer. So 1 times minus 3 is a minus 3, but I'm going to use the opposite of that. How do you recall that this diagonal will be the positive answer, and this one will be changed? Well, one author who liked it in the South, he thought of it as a map of the United States. And he said, as you move south, that's a positive experience. And as you move north, it's a negative experience. So for me, I would flip that the other way. But for most people, they like to go south and Florida and all that stuff. So will that help you remember it? I don't know. But anyway, then you take those two numbers and you add them. And the determinant is 7. Would you try from that one example, would you try the determinant, finding the determinant of this? 2, 1, 4, 2.
Is there like a letter for determinant instead of writing determinant every single time?
No, it's just this symbol like this, so you can say equals. Those bars mean determinant.
Can a
Yeah,
number equal 0?
it does.
Yep,
Anyone
it
else
does.
get 0?
Yeah.
Let's see. 2 times 2 is 4. 4 times 1 is the negative 4. 4 and negative 4 are 0. Well, that was no fun. Let's try one that's fun. All right. 0, 3 halves.
Oh.
This is fun.
You didn't like the last
This
one.
is what I call fun. I don't know about you, Allie, but
All right. 0, 3 halves, 2, 4. It's not so bad. The 2 bleeps out. The half bleeps out.
oh, it's just yay.
On that, I say, but you remember your negative.
Oh, then it's
Yeah.
that.
All right. So when you go along the positive diagonals, you get 0 times 4, which is 0. 0 is always helpful in a matrix. And then you do the negative. 2 times 3 halves is 3, but we use the opposite, so we get minus 3. Minus 3 plus 0 is minus 3. All right. Kramer noticed that you can use matrices in a different way than what we've done to solve systems of equations. So jump right to it. And you'll have a couple to do for homework. Classwork, homework. You can work on them while you're eating your fruit if you want. All right, it works like this. Let me give you the system that we're going to solve using Kramer's rule.
No.
Can you read that? 4x minus 2y, write it down. 4x minus 2y equals 10. 3x minus 5y equals 11. So So we're actually going to use Kramer's rule now. And we're going to find out what x is and what y is. It'll be an ordered pair like this. So we could use substitution or elimination, but we're going to use Kramer's rule. And I'll tell you why we do it this way sometimes, but not just yet. Let me show you what it is first. All right, I'll teach you how to get the x value, and then I'll teach you how to get the y. The x value is a fraction. It has a determinant on the top, which I'll tell you in a minute. But let's go to the determinant on the bottom. It's just the coefficients of the system. The coefficients are 4, 3, -2, -5. The 10 and 11 do not play out in the bottom. I actually told you the name of that earlier when we introduced matrices. That's called the coefficient matrix. It does not involve these constants. So we need the determinant of that. You want to go ahead and get it?
Is it -14?
I got -14.
Yeah.
So that's the bottom of our fraction. So we're hoping for something like 28 or 56, something even on the top, but not always. These can be fractions. So the 6 and the -20. Did you get the -14 okay?
Yep.
-20, and we would have got -6, but since we're going to main, we had to switch it to the opposite sign, +6. Those are added to give you the -14. The thing that's hardest to remember about Kramer's rule is how to develop the matrix you need the determinant for in the top. If you're looking for x, you ignore the x ones. So that's kind of hard to recall. When you're looking for x, you ignore the oops. When you're looking for x, you ignore the x coefficients and you use the numbers that remain. -2, -5, 10, and 11. The constants do come out to play. So did you see that? How I got these numbers? I ignored the x. That's the one I'm looking for. So I ignore the x and I use these numbers. So what's the matrix determinant here?
Is it 28?
Oh, I hope so. All right. I'm assuming 50 and -22 are 28. 28 over -14 is a -2. So that's my x value. Let me show you how to use Kramer's rule for the y. And I'll just go over and write over top of this. The y equals the same coefficient, the same matrix, the coefficient matrix in the bottom. So I already know that it's -14. So I don't have to redo that. Guess what the new matrix, fighting the light switch all
You can see
day.
it better.
Do I have it not covered right?
No, you're
You're
not supposed to
have
cover
it.
it.
Oh, that's right. It's when the lights are out. So that's a cup. And sometimes this is actually missing, and then you have to make one, and it's like, oh, were we really leaving the lights on that much? All right.
It's 4, 3, 10, 11.
All right. All right, so now we're using, I lost my train of thought. Now we're using the the numbers while we're ignoring the y, and as you foresaw, 4, 3, 10, 11. So what's the determinant there?
14?
30 from 44 is 14. Cool. 14 over 14 minus 1 for the y. Alright, so why would you want to do it this weird way when you could just do substitution or elimination and get it pretty quickly? This is very, very computer applicable. You can, in fact, when I learned this in 11th grade, it was combined computer and college algebra class. So they had us actually program a computer to do this, which you can do this much easier. You can get a machine to do this, but you can't get it to think elimination and substitution. You can't do that. You can, but it's a lot easier to use this method. So Kramer's rule has very strong computer applications. All right, could you do one after seeing, you do a couple after seeing just one? All right, let me find that paper. What would it be? Oh yeah, I couldn't, we were out of colored paper. I had to put it on tag paper or whatever you call this. All right, Molly, I'll shine a light on this. This is the assignment. I had to turn the light out to do that. All right.
Cardstock, that's what it is.
Yeah, cardstock. All right, I wanted you to do 1, 2, and 3. Oh.
Of which part? Point. Please, so I don't
Of
get
the second part, probably.
Right here?
1, 2, and 4.
One,
Not
two,
one,
and
I
four.
think. Let me check. I actually picked them out. 1, 2, and 4. Just 3 of them. And I'm going to shine a light on Molly for Molly. Should have left this up. It's weird that you have to turn the lights off to do it, but you do. I might need some of the light from the curtains there. All right. All right, Molly. We are just doing 3, just like the one I did on the board. And there they are. 1, 2, and number 4.
What does it mean, if possible?
I think that some of them turn out to be,
Not those 3.
I think dividing by 0 or something. So those, I picked ones that turn out. Okay, so am I on? Can you see me? Mm-hmm. All right, that's it for our class, Molly. We're about to have our fruit. Wish you were here. I'll show you what the fruit are. Although, have I been taping too long?
I'm not really
I have no idea.
It was only Kramer's rules. I don't think I went for 15 minutes. I'll show you. We've got a fluffy fruit dip.
A fluffy fruit what?
Dip.
Oh, fruit dip.
And I put the fruit on these little kebabs. So let me show you one, Miles. Show you what you don't get. All right. How's that? Is it showing up?
Yeah,
All right.
that looks so good.
And we have this fruity dip to put them in. So, all right. Over and out, Molly. Hope your trip is good. Bye-bye.